lab. So for OSPF we need the two router. I will take one router here, I will take one router here, and we will take two switch. Then we need some computer, we will take two computer here, two computer here, and now we will connect. So here to here we will connect, from here to here, and from here to here, from here to here we will connect. And then here what we will do, in between we will write here the IP address 192.168.12.0/24. so here we will use 12.1, here we will use 12.2, and this side we can use the same thing, 192.168.1.1/24, and this side we will use 192.168.2.1/24. like this we can do. And what else? Yeah, we can do the configuration. So let me do the configuration. First of all, let me save this lab, RIP version 2 lab. So now we will take the new notepad. We will do here, we can write like OSPF lab. So here we will write the R1 configuration, enable config T host name R1, then interface F0/0. I will write IP address 192.168.12.1, give space 255.255.255.0. I will write no shut. Then we have another interface F0/1 here, and I will write IP address 192.168.1.1, give space 255.255.255.0, and we will write no shut. Then we will write router OSPF1, and then network ID we need to write. As we already know, this is a /24. So in that one, 3 portion will be network portion and remaining will be host, so this will become 0. So we can write 192.168.12.0. then we need to write the wildcard mask. Wildcard mask is the opposite of subnet mask. So whatever the subnet mask you have here, opposite of that will be the wildcard mask. So we will write here 0.0.0.255. then after that you will write area 0 like this. Then after that again you will write network, and then write the network ID 192.168.1.0, give space 0.0.0.255. then after that you can write area 0. Okay, then you copy this and paste this in the R1 here. Go here in the R1 and you can put the IP here, put the configuration here, and you can see all the configuration is here, everything is good. We can save the configuration, and we can write the RIP, that is router to configuration we can do. R2 configuration we will say enable config T host name R2, then we can write interface F0/0. I will assign the IP address 192.168.12.2, give space 255.255.255.0, and then we will write no shut. And you have one more interface F0/1. We will write IP address 192.168.2.1, give space 255.255.255.0, and we can write no shut. We can write router OSPF1, then network ID 192.168.12.0, give space, write the wildcard mask, and then write area 0, and then you will write network, again network ID. So here you have 192.168.2.0, then wildcard mask 0.0.255, and area 0. Okay, so this is the RIP version 2 configuration. We will just copy and we will paste here. I will paste here. If you see everything look good, I can save the configuration here. Now we can check. You can go here in one of the router and you can write show IP route. You can see we are getting the route here. This is a routing table. How we can check the routing table? We will write show IP route. So when you write here, you have the code. In this one, we will see what we are getting here. We are getting O. O stands for OSPF. So we are getting this route. If anyone want to go to 192.168.2.0 network, then next hop will be 192.168.12.2. So here next hop will be this one. And from this much time, this route is up and this is a living interface. And if you want to check the show IP OSPF neighbor table, we will use this command show IP OSPF neighbor. So this is a neighbor ID. This router ID is only the neighbor IP. I am standing here, I am checking here. So they are getting this router taken this router ID. We will see how they are selecting the router ID also. So this is the router ID of this router, and by default priority is 1, and we will see the states also. Now this guy is in full state. Later we will see states also. And this router is a DR. What is DR, BDR? We are going to see that also. And this one is a dead timer. This timer will be reduced at last. If this timer becomes 0, they will remove this entry. Before it is becoming 0, the other guy will send the hello message from here to here. So this timer will again reset to 40 seconds. And this is the neighbor IP, and this is our interface which is connected to neighbor. So this is a neighbor table. After that we can write show IP OSPF database. So this is a database table. In that one you can see this is a router ID. Whatever the router ID we have, we will see this, and what process ID we are using, that will come here. And we are using area 0. In that one you have the router LSA, and this is the router LSA information generated by the router LSA generated by all the router within the same area. So here advertised router is 192.168.12.1. Another advertised router is 12.2. So this is the router advertised router. This is the advertised router, and the link ID is this one. Router ID is this one, and this is the sequence number, checksum value they are using. And how many links they are advertising? They are advertising this one link, this one link. So 2 links. Same thing, this router is advertising this one link, this one link. So 2 links. And this one is a network LSA. Network LSA generated by the DR. DR is going to generate the network LSA. So who is DR? That IP is here, and he generate this link. Means this information is generated by the DR. So this is advertised router. So this router is advertising, that IP is here, and link is 12.2. This is a link of that one. So in the OSPF neighbor, we will get the neighbor information. In OSPF database, we will get the database information. So this is the OSPF basic lab we done here.